Hello ladies and gentlemen, and welcome to the third and last non-right angle trig rule. This one actually helps us find area, but can also be used to find sides and angles depending on what information we're given. Alright, it comes from the area of a triangle formula. Now, from previous years, we know comfortably that the area of a triangle is half its base times its height. And this works exceptionally well when we have right angle triangles, because we know that the area is just, if we call that A and B, it's a half AB, or here it's a half times base times height when the triangle looks like that, or this. The problem is, what happens when we're not given this height? Well, when we're not given this height, we'll have to use the sides and angles within the triangle to find an expression to let us find the area. To do this, we take any triangle and drop a center line down it and call it height. And we know that the area to this triangle is really a half times base times height. Alright, but let's pretend we're not given the height. We are, however, given the base and one other side. In addition to that, we're given the angle in between them, theta. Alright, so let's consider this right angle triangle here. By considering that right angle triangle here, I can say that sine theta is equal to opposite over hypotenuse, or in our case, sine theta is equal to the opposite, which is h, meaning the height of the triangle, over the hypotenuse, c being that side. Now, multiplying both sides by c, I can say that h is equal to c sine theta. That's meant to be a little c. Alright, how does this help us form an equation for the area of a triangle? Well, if I know that h is equal to c sine theta, I can say that this h is equal to c sine theta. So therefore, I can say that the area of a triangle is equal to a half times one side meaning the base, times c sine theta. What you'll notice is that we've got a half times one side times the next side times the angle in between. That is a half times one side times the adjacent side times the angle in between. And if we felt like flipping this triangle on its each side, that would work for any triplet like that. So anytime we have, and now my screen freezes, fantastic. Anytime we have two sides and the angle in between, we can use that rule. So for that reason, this rule is written in three different ways. Area of a triangle is either half BC sine A, half AC sine B, a half AB sine C. I should have noticed here that this angle we would call A, so really what I should be writing there is A. Half BC sine A, that's the angle in between those two sides. So in an example, if we're given two sides, angle in between them, we can say area is a half. In this side is called C, this is A, that angle is B, a half AC sine B. Area equals a half times 231 times 150 times sine 123 degrees. Area equals please remember the units. You'll lose marks without units. Unless the question has no units, like this one. Similarly here, we're given area and asked to find a side. So are you familiar? We can label this A, B, C, C, A, B. If we know area and we want a side, we can say, well, area is equal to a half. In our case, BC sine A. Area is equal to, and which we know what area is, so area is 40, is equal to a half B, which is x, times C, which is 10, times sine 35. Then to get x by itself, we would do 40 divided by a half 10 sine 35. 40 divided by 0.5 times 10 times sine 35. 13.95. Similarly, you could be asked to solve for theta. Bear in mind your last step for a theta solution would be sine inverse of whatever was left on the other side. Alright, thank you very much. No OneNote question today. Enjoy.